Hello class, and welcome to Chapter 4, which is about systems of linear equations and inequalities. Today we're going to start with Section 4.1, which is about solving systems of equations by graphing. By the end of today's lesson, you will be able to identify the types of systems of equations, as well as graph to find their solutions. So when we're talking about systems of equations, what that means is a set of equations that have the same variable. In our case, we're just going to be looking at two equations with the same variables. When you get to high school, you're probably going to be looking at 3, 4, even potentially 5 sets with the same variables. So what it means is, for example, if I had y equals 2x plus 4 and y equals negative 3x minus 7. Those are two equations with the same variables, and so that is a system of equations. The solution to a system of equations is where those lines intersect. So that is the one point or multiple points or no points where the two equations have the same answer. So that means whatever we solve for here and here, both of the y's would give us our same values. So we plug in the same x and we get the same y. When you write out the solutions, those are written out as ordered pairs. Again, we're looking for the place where these two lines intersect. And on the graph, when things intersect, we write that intersection as an ordered pair. There are three options for the solution sets, or the types of equations that we're going to have. So our first option is the no solution. That happens when our lines are parallel. So if this happens, our slopes are the same, but our y-intercepts are different. So the slopes are the same, but the y-intercepts are different. The second type is when we have a pair of equations that have exactly one solution. So that's right here. Both the slope and the y-intercept, the slopes are different for these equations, and they may or may not have the same y-intercept. That really has no effect on determining the solutions. So if both of the slopes are different, that's when we're going to end up having one solution. And then our last option is infinitely many solutions. What this means is that it's the exact same line. So the slope is the same and the y-intercept is the same. So it's the exact same line. So that red line would be right on top of that blue line. It's two different equations directing you to the same line. So the first method that we're going to use, which is the focus of today's lesson, is graphing. Graphing is the least precise of the possible ways to solve because it is not an exact answer. So when we put the lines on the graph, we might have a little bit of leeway if our ruler was a little bit to the side or if we didn't draw a perfectly straight line. So it can get us pretty close to the answer, but it might not get us the exact answer. But we start with graphing because it's the most visual and the easiest to see how these problems work out. So with this first one, I've got y is equal to negative 3x plus 10. So my y-intercept is 10. My slope is negative 3 over 1, so down 1, 2, 3 over 1. And then I'm going to connect those with a line in a minute. And then my second one starts at negative 2, and my slope is 1 over 1, so I'm going to go up 1 and over 1. Now, when we are drawing in those lines, it is very important that you are using a straight edge, whether it's a ruler or a notebook, or a note card, anything with a straight edge, because it's important that these lines are as straight as possible. So when we are drawing these lines, we also want to make sure that we are going through the entire space that the graph allows us, because it could intersect anywhere on the graph. So I drew all the way through the end of the graph to give myself the maximum potential to figure out where they intersect. I'm going to do the same thing with this other line. As I draw that, I'm going to go all the way through the graph. And we are looking for the place where they intersect. In this case, our intersection is at 3, 1. Now, you are able to go back and check if this is actually the solution. So if I plugged it in, negative 3 times 3 is negative 9 plus 10 is equal to 1. 3 minus 2 is equal to 1. So this intersection point is, in fact, the answer to our graph, or excuse me, the answer to our system. If you notice, my intersection was not perfectly at 3, 1, but it was pretty close. When you are graphing, you want to go with the closest point of intersection. Even though your graph isn't going to be perfect, that closest point is probably the actual answer. And again, you can plug it in to check if it is the correct answer or not. Go ahead and try this one on your own. So we graph. The first equation has those red dots, the second one with the blue dots. Our point of intersection, again, you can see it wasn't a perfect intersection, but it's roughly at negative 6, negative 3. Again, we can plug that in to check if that is our actual answer. Some of the times we're going to have to rearrange the equations in order to be able to graph. This is something we are familiar with from our first couple of chapters. So this first one is already in y equals mx plus b. So starting at negative 3, going down 2, and to the right 1, that's going to give us our first line. Our next line right here is not currently in a form that we can graph. So we need to subtract 6x from both sides. And when I do that, I get 3y is equal to negative 6x minus 9. I put that x in front, so it's y equals mx plus b. Then we're going to divide all of the pieces by 3. So I get y is equal to negative 2x minus 3. Notice now, we have the same slope, negative 2 and negative 2, and the same y-intercept, negative 3 and negative 3. So my points end up at the exact same location. So if I were to graph this line, again, using a straight edge, I would go through and I would have this for my red line. And then if I went through and drew a second line, I would get the exact same line again for the blue line. So this is an example of what all or infinitely many solutions would look like. Because every single time we touch this black line, we're touching points that would solve the first equation and touching points that would solve the second equation. So this one would be infinitely many solutions because it's the exact same line, the same slope with the same y-intercept, two different equations. Go ahead and try this one on your own. When we rearrange this one, this first line corresponds to the first one, the second line corresponds to the second one. Notice, we've got the same slope, 2x and 2x, but we've got different y-intercepts. That puts our line as parallel, and that gives us the no solution. Last thing, a quick word problem. So we've got Joe and Josh want to buy a video game. Joe has $14 and saves $10 a week. Josh has $26 and saves $7 a week. How many weeks until they have the same amount? So we're going to start with Joe and his equation. It says that he has $14 and saves $10 per week. Remember, the slope is what's changing, so we're getting $10 per week plus the 14 that he already had. And then for Josh, we've got, he has $26 and he is changing by $7 per week. So that's his slope and y-intercept. In order to fit this on the graph, we're not going to be able to count by ones. So I'm going to go ahead and count by 5. So 5, 10, 15, 20, 25, 30, 35, 40, 45, and 50. That's going to give me plenty of room to figure out how much we are going to need, or give me enough space to find where those lines intersect. So starting with Joe, his initial amount was at 14, and he goes up by $10 per week. So up 10 and over 1 for the week. So he's got $24 after that week. And then we've got Josh, who starts with $26 and is going up by $7 per week. So if I do 26 plus 7, that's going to get me 33. So that's going to put me right there. And then I'm going to want to go ahead and graph my equations, again, with a straight edge so that our lines are as straight as possible. And when I do that, I am going to have this line right here. And for Joe, it's going to be this line right there. So as we are graphing those lines, we can see that our intersection point is at about 4. So the answer would be 4 weeks. Again, graphing is not super precise, so we can plug this into double check. 4 times 10 is 40 plus 14 gives us 54. And 4 times 7 is 28. 28 plus 26 also gives us 54. So it is correct that after 4 weeks they have the same amount. If you have questions about this or anything else from the lesson, please let me know when you get to class.